All right, we are back for a challenge. After the bubble sort video I did, uh, one of the commenters wanted me to try that with Quicksort. Uh, actually, I may have to leave. I'm on the side of a highway right now. Somebody's coming. I thought they were. They turned into the lot, but there's a little hill thingy here, a little rise that I can't see. Never went by that. But I think it was the same truck I saw last time I was here. If you guys don't know, I live in my truck with two dogs. So I find different places to stop and program. Anyway, all right, whatever. All right, we're going to go. Let's do it. Okay, Quicksort. Um, Let me pull up the Wikipedia thing. I remember Doug Crockford talking about you take 2 pointers, one on the left side, one on the right side, run them towards each other, and then you swap out values, that belong on either side of a pivot. That's all I really know of Quicksort. Besides, I know it's built into C, um, but that's it. I don't know. Maybe that's all I need. Is that all I need? Um, is it, or should I Google it and read a description? I'm gonna go with what I know right now, and if I need to get into it, we'll Google. All right, let's go. Let's see. File stream. All right, we got that. Ooh, we're off to a good start. Okay, what do I need to do? I need some numbers to sort. Say numbers equal. Whoops. Gonna do 10. Let's see, 9. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9. One more. And of course, you got to have 1 at the very end. All right, those are the ones we're sorting. Okay, what am I doing here? Can't do that. All right, make sure it works. 9, 3, 8, 2, blah, 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 blah. Okay, looks good to me. Is it all on one line? Oh man, there's a fly flying around here. Hope my dog don't see it. He'll go crazy. All right. All right, so we got them like that. All right, let's do the work. Okay, so what am I gonna need? I'm gonna need, so what? This is gonna have to be recursive. So I need a function. Let's do a function up here. Let's see, what's it returning? Nothing? Maybe an array? No. We need to make it accessible. Hey, I need all the help I can get here. So do that. Make sure we're still good. Okay, still good. Okay, so we got that. Now we need a function that, what, does void? So it calls itself. It's going to be doing that. Okay, so if we do that. No, we don't need it like that. We could actually pass it in from main. Let's leave it like this for now. Quicksort. And then I'm going to need what? Left and right, because we're going to end up having to redo this on the left and the right until there's nothing more to sort. So, let's see. What do we need? Left, right. I don't know what else right now. So that, now if we're working off of this, or the global, okay. Okay, first of all, we need our statement. What's it called that ends the recursion? Can't remember what it's called. If was it left? So we would end it when we have like one number. So if we said, like we start here and here, on the right side it's looking for, and we have a pivot. Let's say our pivot is 38. So things that are greater than or less than 38 have to be swapped. And the left side, if it's greater than 38, it would get swapped over there. But see if it is, or should I randomly pick the pivot, or should I just take the 9? If I take the 9, then anything less than that would be swapped over. So we'd say 3, 1, that gets swapped. 38, 101, that does not. Because the first time through, if we do all our swapping, let's just say they go to the middle and they meet. So that means from here to there, this right here, would have to be sorted. So we do need the left and right to be the indexes on that. And then when they meet or pass each other, I wonder if that would be it. I may have to read the description. Uh-oh, my dog has seen the fly. Oh, I never connected. Wait a minute. I'm going to start my hotspot. We are on. Okay, here's the one from Wikipedia. Okay, blah blah. Blobbity blobbity. Let's see. Okay, history. Don't care. It is interesting, but I do not care at the moment. Okay. Blah 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 blah. So at least 2 elements. So I probably do need to pass in. Let's go ahead and pass in the array. No, actually I can pass in the indexes. Because we're going to need an algorithm that actually does the comparisons. So once I call Quicksort, it's going to run the actual algorithm. I'm thinking. I need coffee. Well, if you thought bubble sort took a long time. I think it's going to be longer than 19 minutes. Sparky, are you going to go sleep? Lay down. Hey, Twig. Dang it. My other dog's underneath the laptop because it's kind of sitting on my knee, and he's way under my legs. He's all skittish, and he just about knocked everything over. All right, Twig, you can get up here. Get up here. Sparky's gone. All right, lay down. Unless you guys know how to do Quicksort. All right, back to the description. Produce the division into 2 consecutive blah 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 in such a way that no elements are greater than Is it cheating if I see the steps? Probably is. I need to read this. Go off that. I think, because I mean, I've read about it in the past, and I know the partition, there's different ways to do it. You can take like the middle, you can take the beginning, you can take a random one. I think I'm just going to take the first number. Because if I remember reading right, that there was no evidence that anything, other than the first one was any better than just picking the first one. Okay, let's just make this simpler. So let's do a partition here. Okay, so where do I even do that at? So I should, do I have to pass in the partition? Hmm. Like that, and then call it from here. So that we would do that. So if I do quicksort, 0, comma, what, 10. Actually, that would be 9, wouldn't it? N minus 1, 0 to 9. And then the partition, we'll just say it's 0. Okay, let me see that. So if I do that, does that mean I have to start the left index at 1? I think it does. How do you even handle that anyway? So if I need to, so if I'm at 1 and the other one's at 9 and they swap, so that goes there. That means the partition is always staying at 0. So when do we actually move the partition into place? Maybe I do need to look at the steps. Because if I think about it, it's not going to help the algorithm. I mean, once you do everything. Oh, wait a minute. So if I'm balancing, if I'm throwing things left and right, swapping them by the pointers and they're running in, once they meet, I wonder if that's where the partition's going to be. Maybe I'll go with that. Okay, so let's do that. So we come in, blah, blah. So we're going to do, so we need another function that actually does the swapping. Or is that this function? Let me see. Actually, we don't need the partition anyway. Um, It'll always be 0. It's always going to be 0. Well, if we have that, then we don't even have to have the partition. Or actually, it'd always be the left pointer. Because even if we did the right side, wherever the left is, well, no. Do we pick a partition each time we run the quicksort on the subsection of the array? Okay, I have too many questions, so I'm going to read the steps. Let's see. Says for in place. I think that's the one we want. Okay. We just view the two elements return me like blah blah. Okay, so that was what stops our recursion. So we got fewer than 2. Let's see if right minus left. Listen to, then return. So then we have blah 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 blah. Okay. Pick a value, call it pivot. I don't think we need it. Okay. So now our pivot equals 0. All right, what did I do? Go back. Partition. Okay, reorder elements. So values less than the pivot come before the division. Greater than the pivot come after it. Sorry. Either way, it's present. Than the original or produced. So should we just take it as that then? Divide by 2? So we'd have 83. That would be a bad one. I'm going to go with that other one where we just pick that. So in this case, it would be 9. It's probably equally bad. Okay, now what? All right. Hmm. So we swap that. Okay, otherwise, because if one needs to be swapped but the other doesn't, we need to stop the one that needs to be swapped, but the other one has to keep moving. So, numbs left. We're gonna have to break this up. Let's just do this. So if left is less than pivot, we don't need to do anything there. Or equal. No, I guess we could do that. So if left number is less than pivot, then it's already on the right side, so let's do that. Okay, so those are moving. Oh, so if it's equal or needs a swap, we go down here. Um, or maybe we should do the other one first. I don't think it matters. So here we've already, yeah, because we've already moved them. So we got to do this up here. Do that. So once we swap, we need to go ahead. That's the end. We don't need this anymore. There. Nah, we don't need the else on that. Because we could put these in an else. Probably better. Don't need that. Okay, so we do a swap. Increment, blah, blah. So once they meet, they're going to break out of here. And then we need to call again. Let's see, Quicksort. It'll be what, left? Wherever they meet at. So what would that be? 0 to right? Quicksort. What would that be? Left, comma. To the end. Yeah, that's the part. I don't understand that one. Wherever they meet at. Because in this case, or should I actually do left plus 1? Because that's going to be the pivot. I don't know. I know I'm probably making this way too complicated. But yeah, I don't know what to do once. So I know you'd have to keep going. You'd have to. Hold on. If, because see if they meet. How do I know where it was though? That's what I don't know. Hmm. I don't think I can. I don't think I can figure this out. I'm stuck at that point. I'm going to run one pass right there. And then we're going to print it to see what happens on that. Okay. Let's not take 3 arguments. Where's that? Oh, forgot that. Main. So it did some of them. So 9, 3. So 1 and 38 swapped. 7 and 10 swapped. So after the swap of 7 and 10, so start at 3. Because if it's left, it skipped 3 because it's less than 9. 38 is greater than 9. 1 is less. So 38 and 1 should have swapped. And they did. So that was right. So now that works. Then went to 101. And that one went to 10. 10 is greater than 9. So that needs to swap. 1 on 1 is greater, so that should go into 32. 32 is greater, so now it goes down to 10, or 7. 7 is less, so now 10 and 7 swap. And now left is 83. That's greater than. So now right is 5. That's less, so those swap. Then we have that. So at that point they meet. So that means we can put that 9, the index, well, we'd still have to swap it. We'd probably swap it with the last one, you know, on the left side. uh, so at the very end, once we exit, oh, let's see. We want pivot to be what, where they met? So temp equals let's see this again. So in this case, they're both at 83 when it stops. So if we go one less than that and swap it out, let's see if that'll work. I don't think it'll work when it's even. As a matter of fact, when they're even, this is not going to work. Well, yeah, it will, because it'll go past, right? So let's do it at, let's see, temp equals nums left minus 1. I don't know if that works in all cases. If we only have two numbers and it goes past each other, of course we could have a special routine for that. Temp equals, unless it's 0. Anyway, let's go with this. Temp equals minus 1. And then left minus 1 TMP. No, we got to put it back in num0. Hold on. It's right here. Because nums is our... Well, we don't need to know that. It's always 0, so... see, num0. And then nums left minus 1 equals temp. Num0. No, it should be temp equals left minus 1. So then num0, got confused for a minute, equals what t? Num's left. And then num's left. Whoops. It's 1 equals TMP. So we've got everything partitioned on that. But now what if you had something like 109? Whoa. The heck is going on? Like one of my keys stuck or something. Oh, I'm leaning on the headphone control. Oops. I forgot I had a control on it. Okay. So if we do something like that, is it going to mess it up? Is you're doing that -1. 109. Because everything is going to be less than the 109. Except for that 1. How come the 1 didn't go over? Because it was -1. So that's definitely not the way to do it. I'm not sure how you figure out where that goes. Okay, I mean that took care of that one, but but now does it work with that? No, because we ended up with 83 at that point. But could do this. Okay, so that's the number of your pivot there. Oh. So starting from where left is, it's got to be where they meet. You know what? Right here. They meet or this goes ahead. So if left is greater than pivot, that means we're ahead of right. If left and right are the same, okay, hold on. So if left equal to right, then all we need to do is do the regular swap with 0, which is this. else. If left is greater than right. Because there's only two cases where it's either greater than right or equal to right. I think. Yeah, it's never going to be less. So we just need this. I'm going to be specific. Just to try it. Left is greater than right. So in this case, we need to actually swap with right. I think. Let's try that. But this, it's not all, well, yeah, because it's the pivot. So actually, we can take that out. Let's put it here. So then we just have that, but with right. Copy that. Like that. Okay. So that one worked there. So now if we add our 109, so our pivot was 109, so everything is below 109. So that worked too. But now if we make it 1, make that 11. 11. It's not right. So that one was definitely not right. So on these, the left started at 3. Right is 11. Everything is greater than 1. So left should never, right should be right here on the 11. It's not less than 1, so it's going to go move forward. This is going to go forward. This moves to there. This goes to here. That goes to there. Right goes to 5. They should end up equal at this point. 1, 2, 3, 4, or maybe not. Yeah, because it goes here. 1, 2, 3, 4. 1, 2, 3, 4. So they both end up at 5 when they meet, and nothing's been swapped. So at that point, temp equals 1. Left does equal right, so nums 0 equals nums left, which is 5. And nums left equals temp, which is a 1. Oh, wait a minute. Left got stuck right here. Because left is looking for things that are greater than the pivot, and right is looking for things less. So right goes bloop, all the way over here. They meet on 3. That's what's happening here. So they're both equal. Nothing swapped. Temp is 1. Left does equal right. They're both 1. So nums 0 equals 3, which is right here. Nums left, which is 1, equals 1. So at this point, we need to check to see if it's already in position. So if nums 0, or actually TMP really, if TMP is what, greater than left, greater than or equal to left, nums left. Well, here, we'll just do this. If it's less than, then we'll do the swap. So that way we ain't got to do any brackets. Then we do our swap. Is my interview time over yet? Very first question. So do that. Well, everybody knows I didn't memorize it. That's for sure. Okay, so uh, okay, so in that case, but that's only if they equal right. It should be the same thing here too, except instead of nums left, we're going to do nums right. So I always mess it up when I copy and paste. So let's just write it out. So if TMP, is it still nums? Yeah, still less than. That's right. Then we do the swap. That. One day I'll have to tell the story of my Google interview. Yes, I got the interview at Google. I know you can't believe it. Okay, back on task. All right, so let's test this. And this was not one of the questions either. Let's do that. Well, that still didn't work. Let me see here. Blah, blah, 1. I probably messed this up here. So, left and right are equal on this. Pivot. Okay, temp is num 0, which is... Oh, wait, it's a 1. It's a 1, so if 1 is less than num... Oh, oops, I had the reverse logic. If temp is greater than, then you want to swap. Reverse logic. When I was at Tyson Foods, there was this gnarly logic bug. I mean, it just went down the screen like this. It was like nested 5 or 6 deep, and it was all logic, and each one of them had 3 or 4 different things going on, and it was so crazy. That thing was gnarly. I grabbed this old man that worked there. He was a COBOL programmer. And he came over, he looked at it. I mean, it wasn't like 3 seconds. He already found it. It was crazy. But sometimes the lesson there is sometimes you can stare at something so long that you're not gonna see it. You might as well just go grab somebody. You get another pair of eyes on it. That's what it's called. Okay, what am I doing? Back on task. Let's go. I got to get this done before the sun sets. Okay, back there. Okay, that's finally working. So let's go back to our original, which is 9. What was that one? Oh, 1 at the end. Yeah. See if that one still works. There. 950, blah, blah, blah. Yeah, that one's not doing it. This. Well, no, it did it. Yeah. Pivot's 9, so everything over here. So that part of it's working. So now I got to get it to where I can recurse with each side of that. Man, this might have to be like a part 1 and part 2. What time is it? 3:16. I think I started at like, what, 2? Okay, we got that part done. So now I need to call, what, quicksort again with left and right. Actually, I need like a, where's it at? I call it here, 0 through 9. So at some point, I need to recurse from here. All right, guys, I'm going to call this part 1. This is to be continued. This is going to take another hour or 2. All right. Don't tell me the answer in the comments. I need to figure this one out. All right. Thanks for hanging out with me. Um, hey, stay tuned. This is building up to the final crescendo, the peak of senior devness. All right. Hey, if you like this stuff, please like it. Consider subscribing. Share the channel. Please, it helps. Okay. I'm out of here. I'll see you on the next one. I promise I'm not going to cheat and look. Bye.